In these sections, I'm going to introduce you the mammalian kidneys and their roles in urine formation. The mammalian renal system consists of a pair of kidneys and urinary tract. The kidneys are bean-shaped organs consist of an outer cortex, an inner medullus, and innermost renal pelvis. Blood in kidneys is supplied by renal artery and drained by renal vein. Do you know why kidneys play an important part in the excretory system? By the way, all vertebrates have kidneys. However, they may be different slightly in the structures and functions depending on their adaptations to the environment in which the animal lives. Kidneys are important in eliminating the body metabolic waste products and selectively reabsorb substances that are needed by the body. These materials are filtered out of the blood into the kidneys, form into urine, and move out from the ureters into the bladder before being expelled through the urethra. Thus, blood in the renal artery contains glucose, oxygens, and body metabolic waste product, whereas the filtered blood in the renal vein is free of cellular waste products. So let's take a closer look into the kidney structure. They are made up of millions of functional filtering units called nephrons. And each nephron consists of a glomerulus that is connected to the proximal tubules, a long U-shaped tubules called the loops of Henry, extend to the distal tubules, and connects to the collecting tubules. And collecting tubules transport the urine and delivers it to the renal pelvis into the ureter. Have you ever wondered how urine is produced? To produce urine, three important processes are involved. These are glomerular filtration, tubular reabsorptions, and tubular secretion. Let's take a look at the glomerular filtration process, which is the first step in the urine formation. The glomerulus consists of a cup-like structures called Bowman capsule, in which a cluster of very thin wall blood capillaries reside. Filtrations of the blood contents occur in this capsule. Where does the ultrafiltration pressure come from? You may wonder, right? This high hydrostatic pressure is mainly caused by the heart pumping actions that forces the blood through the glomerulus. As the blood flows through the glomerular capillaries, plasma containing dissolved low molecular weight substances such as water, nutrients, waste, and salts enter into the Bowman's capsule by ultrafiltrations and form urine. The sieve-like endotheliums hold back the blood cells, large and smaller proteins molecules. The second steps of tubular reabsorptions occur at the proximal tubules. Important substances for normal body functions will be reabsorbed from the tubular fluid and returned to the blood in the renal vein. For example, sodium, glucose, and amino acids are usually 100% reabsorbed. Do remember that energy is required for this process. Energy for reabsorption is supplied by sodium-potassium ATPase pump on the basolateral surface of the tubular epithelial cells. So in the proximal tubules, about 65% of the sodium ions is reabsorbed. There is a counter-transport of the hydrogen ion that accompanies sodium ion reabsorptions in the proximal tubules. Glucose and amino acids are also reabsorbed by co-transport with sodium ion. Water is passively reabsorbed in the thin wall of the descending loops of Henry, which is water permeable but impermeable to solutes. And about 25% of sodium ions is actively reabsorbed in the ascending tips of loops of Henry, which is impermeable to water. The remaining sodium ion is reabsorbed through the co-transports of chloride ion. It is also moderately permeable to urine. Tubular secretion, which is the last step of urine formations, occur at the distal and the collecting tubes. The distal tubules regulates the potassium ion and sodium chloride concentrations of the body fluids, whereas the collecting tubules carry the filtrates through the renal pelvis for the removal. Toxic substances such as urea, uric acids, and others are eliminated. Have you heard the words creatinine? Creatinine is a nitrogenous byproduct of phosphocreatine breakdowns in the muscle. And these substances is filtered at the glomerulus and secreted and will not be reabsorbed. Because creatinine is produced at a very constant rate on a daily basis, it is found to be a very good indicator of the kidney function. Increase in the creatinine level in the blood may indicate kidney disease or kidney failures. So in summary, kidneys play an important role in the blood filtrations and urine formation. And 3 steps involved in the urine productions are identified. These are glomerular filtration, tubular reabsorptions, and tubular secretions. And approximately 180 liters of blood plasma is filtered through glomerulus daily, with formations of about 1 to 2.5 liters of urine per day. And about 99% of the glomerular filters is reabsorbed. So I hope you enjoy this video.
Audio Jungle.